Welcome to another new video of interesting math problem on our channel Math Solutions for You. Please do like, share, comment, and don't forget to subscribe to our channel. An isosceles triangle with each equal side of length 16 units is inscribed within a circle of radius 10 units. What is the area of the triangle? So we start this problem from the figure of an isosceles triangle being inscribed within a circle. And let's name the triangle ABC, and then the center of the circle O. And one of the first things we do is we start with some constructions. We join the vertices A and C with the center O. And AO and OC, these are basically being the radius of the circle, these are equal. So that makes triangle AOC an isosceles triangle. And if we drop a perpendicular from O onto the side AC, we know that this perpendicular will, let's call that OL, so it meets AC at L. So this perpendicular will bisect the side AC, and it will also bisect angle AOC, so that angle AOL will be equal to angle LOC, and let's call each of those angles as theta. So this is from very basic properties of an isosceles triangle, right? So if angle AOC is 2 theta, because each of those angles AOL and angle LOC are theta, so they add together to make angle AOC as 2 theta, then angle ABC will be theta, half of angle AOC. Why is that? Well, there's a theorem which states that the angle subtended at the circumference by an arc of a circle is half the angle subtended by the same arc at the center of the circle. So if we consider the arc AC, it subtends an angle AOC at the center O of the circle, and AOC is 2 theta. And the same arc subtends an angle ABC. So angle ABC will be half the angle AOC. So if AOC is 2 theta, then angle ABC will be simply half of 2 theta, which is theta. So what's next? Well, now we just replicate the figure, but instead of the constructions that we have done, we do a different construction. We basically drop a perpendicular from the vertex C of the isosceles triangle onto its base AB. And this meets the base AB at the point P, right? And we know that angle ABC is theta, right? And let CP, the length of CP be Y, and length of PB be X. So now consider triangles AOL from the first figure, and then triangle CBP from the second figure. Now these two triangles, their corresponding angles are similar. They each have a 90-degree angle, and then one of their other angles is theta. So that makes the angles of these two triangles similar. So these two triangles are similar, and we know that similar triangles have this property that the ratio of the corresponding sides will be equal. So in this case, CP by CB is equal to AL by AO, and CP is Y, CB is 16, AL is 8, and AO being the radius of the circle, that's 10. So we have y by 16 is equal to 8 by 10, from which we can solve for y, and we get y equal to 128 by 10. Now, if we consider triangle BCP, and that's from the second figure, from Pythagoras theorem, we have from the right angle triangle BCP, CP square plus PB square is equal to square of the hypotenuse BC square. So CP square plus PB square is equal to BC square. So what is CP square? Well, CP is y, and PB has been x, and BC is 16. So you can write y square plus x square is equal to 16 square. We know that y is equal to 128 by 10, so we substitute that, and we can solve for x from this particular equation. And this is a little bit of math, so we get x square is equal to 16 square minus 128 square by 10 square, which we can write as 10 square in the denominator. Then in the numerator we have 160 square minus 128 square. And then to avoid calculation of the squares, I basically use the formula of a square minus b square equal to a plus b multiplied by a minus b. So I don't have to actually calculate those squares of those large numbers. And I basically get in the numerator 160 plus 128 multiplied by 160 minus 128. And the denominator I still have 10 square. So we have x square is equal to 288 multiplied by 32 divided by 10 square. And then 32 can be broken up as 2 into 16. So 2 into 288, if we take that together, that makes 576. And then we have 576 multiplied by 16 by 10 square. And then we take the square root of these. We know that square root of 576 is 24. Square root of 16 is 4. So we are left with 24 multiplied by 4 divided by 10 when you take the square root. And of course, x being the length here, it's a positive number, so no need to worry about the negative square root here. And this comes to 48 by 5. Now, once we know what x is, we have already calculated what y is. So the area of triangle ABC, AB is the base of the triangle, right? And CP is the altitude. So area of the triangle is half base multiplied by altitude, so it will be half AB multiplied by CP. But then remember the property of the isosceles triangle, that when you drop a perpendicular from the vertex C, here the equal sides are AC and AB, so you drop a perpendicular from vertex C onto the base AB, that perpendicular will bisect the base so that AP is equal to PB equal to x. So AB will be equal to 2x. That makes half of AB is equal to x. So we have half AB equal to x and CP is y. So the area can be simply written as x multiplied by y. And we've already found out what x is and what y is. So we just substitute those values and we get the final answer as 3072 divided by 25. And you can express this as a decimal, which comes to 122.88. So that's the area in square units for triangle ABC.